Hi my dear students, now we are going to see the topic, that is analysis of heat engine, which comes under the case study of the heat engines. So dear, before that we have to see what is heat engine first. The heat engine is nothing. It is an engine, it is a machine which will produce energy from the heat. The heat will be supplied by the chemical formula, chemical energy, which will that is the diesel. So the chemical energy from the diesel, which will be converted as a mechanical energy, that is in the form of heat energy, by the means of these heat engines. Then we have to see the modern diesel engines are hugely important to us, because the most of the heat engines, that is the diesel heat engines, which will be used for the transportation purposes, so especially for the truck transportation and for the heavy bus, and on normal days the cars also, which will be used for it is also running by the diesel engines. So we are taking this topic for analysis. Now, the widespread adoption of the cleaner, most efficient diesel engines and the associated energy security benefits was accelerated by tremendous technological advances made through this research. And the basic combustion research, before going to study this the heat engines, we have to study the basics. The diesel engines was invented in the year 1890s, and in the year 1970 and 1980s, in between these two 1970 and 1918, the extent to which the engine manufacturers could refine their products was limited by the lack of fundamental knowledge about the combustion process. Why the long-term research was happened in particularly in diesel engines? Because it is the most reason for the air pollutions, because the vehicles, nearly almost 75% of the vehicles are in the road, which was operated by the diesel engines. So the basic research is risky and long term, and that's why the most of the companies are doing their research in heat engines. And before that, studying the heat engines, first we have to produce how the energy which will be produced by the diesel engines. The diesel engines, which is having two types. The first one is two-stroke diesel engine, and another one is a four-stroke. Why the two-stroke and four-stroke? By which it is called a two-stroke engine, and by which it is called a four-stroke engine. The two-stroke engine is nothing. In the two strokes, when the piston is moving from top to bottom and bottom to top, in the two strokes, it produces the energy. The 4 cycles will be completed in this two-stroke. But in the four-stroke engines, the piston is moving from top to bottom, bottom to top, top to bottom, and again bottom to top. So in these 4 strokes, it produces the energy. That's why it is a 4-stroke engine. So in this, first the intake and the compression and power and exhaust, everybody we know. Why it is intake? The air alone is enter into the cylinder, and the compression where the air is alone enter. After that it was compressed. This is called compression stroke. Then the power stroke, when it reaches the top dead center, that is at the topmost position, then after that the diesel fuel injected the diesel, then due to the high pressure and high temperature, then it started to burn. Then the burned gases is pushing down. So that is the third stroke, that is called the power stroke. So with this stroke only we are getting the power. For other 4 strokes, other 3 strokes, we have to supply the power. Then after that, the exhaust stroke, everybody know, after the power production, then the piston is upward direction, then it is moving down, it's the downward direction. When it is moving to the upward direction, that's why the exhaust port, exhaust valve will be opened. Then the burned hydrocarbons, the burned the items that will comes out, it's the last stage. So this is the 4 strokes where the power will be generated. Then this is the 4 stroke. It's the first one is that is suction stroke, second one is compression stroke, third power stroke, and the final one is exhaust stroke. Then it's a emission. So we are here. I have given one graph where the emission the emission produced by this heat engine was dramatically reduced in the year, it's compared in the year 1990 to the 2010, where see the emission NOx, CO and HC, hydrocarbon, unburned hydrocarbon, carbon monoxide and nitrogen oxides, then it is shown. So it is due to this lot of researchers. It's a lot of the engine manufacturers who they are involved in, particularly for diesel engines. They are involving in a lot of researchers. Then only we got this kind of outcomes. And especially we are in this slide, we are going to see the technologies for economy and emission reductions. The first one is fuel injection. So in the olden days, the fuel injector alone is placed at the top of the head center, top of the cylinder head, where it injected the fuel. But during 1980s, the research was started, where the fuel injection methods was deliver the fuel at a high pressure. In the 1990s, the fuel injection started to be managed electronically, where all which was controlled electronically by the chip for more precise control of the combustion. Exactly at the end of the compression stroke, where the fuel injector will injected, it is common rail system, because where it will be when the fuel will goes inside the cylinder, where common rail methods or the common rail, the fuel injector will be arranged in the rail structure. So by the way, we can reduce the maximum of emissions. These advanced systems will reduce the soot formation in the engine emissions. Also cannot be proved, rather depends on environmental experimental observations. Then turbocharging. Turbocharging is nothing. It's a very simple. It's a turbocharging uses would have been wasted the energy in exhaust gases, we know. So exhaust gases which is having a lot of heat energy. So that heat energy which will be used, allowing engine to produce more, that heat energy will be allowed into the turbine, where the turbine will be generated very pressurized air. After that, the outcomes comes out, the outlet from the turbine, which will be again supply nothing, that is a outlet of the exhaust gas will be allowed into the turbine, where the turbine will produce some amount of energy. So this increase in power enables automakers to use smaller and lighter engines, increasing mileages while reducing the emissions. Then exhaust gas recirculations, where the exhaust gas which is having a lot of energy, it's a heat energy, no? So the exhaust gases are pushed into the cylinder along with the intake air again. So already the heated inlet air will be goes into this, and the fuel will be mixed into the cylinder. Then we can, by the way, we can reduce the NOx emissions, and also we can increase the efficiency of the diesel engines. Then homogeneous charge compression ignition engine. So where the HCACI, which is an advanced fuel injection technology, it differs from traditional normal diesel engines, where the fuel injection, the fuel and the intake air are first mixed and then injected into the engine simultaneously. The results in lower temperature combustion that occurs more uniformly throughout the cylinder, reducing NOx and PM, particulate matter formation. So nowadays the various researchers are focusing on reducing the cost of improving the performance of HCACI. And the diesel particulate filter, the particulate matter which will be emitted during this burning. So it's a standard, the filters that as a result of EPA, the standard requiring reduction in PM emissions from the diesel powered vehicles. So the diesel particulate filters are used in many passenger and commercial diesel engines to physically filter these exhaust gases. So by the way, the particular matters will be stopped in this filter, and then the fully burned gases alone will be exhausted. And the catalyst, for the past decades, the catalyst has been used in the diesel engines to reduce the NOx emissions. The catalyst or the chemical compounds to transform NOx into the nitrogen gases. So by the way, the emitted NOx gases which will be converted to the nitrogen gases by adding the catalysts. So various design of experiments researchers has been focused for improving the durability and also the performance of the various catalysts. Thank you.